Everyone, welcome back. I'm so glad you're here because this module is one of my absolute favorites. And I think once we get into it, you'll understand why. We're talking today about eradication programs, and I want you to pause for a second and appreciate just how audacious that concept is. We're not talking about managing a disease on a single farm. We're not even talking about reducing it in a region. We're talking about eliminating a disease permanently from the entire planet or from an entire country. That is one of the most ambitious undertakings in the history of veterinary medicine, and it's happened more than once. Here's what we're going to cover in this module. First, we'll get really precise with our terminology, control versus elimination versus eradication, because on the boards, you need to know the difference cold. Then we'll walk through the 6 feasibility criteria that help us decide whether eradication is even possible for a given disease. And then we'll do 3 case studies. Rinderpest, the greatest global veterinary success story. Brucellosis, a U.S. program that got tantalizingly close but hit a wildlife wall it still hasn't gotten past. And Pseudorabies, a U.S. success story that took 15 years and gave us one of the most important tools in modern eradication programs, the DIVA vaccine. This entire module is directly mapped to the ACVPM blueprint under disease control programs. So let's get into it. Let's nail down the vocabulary because these 3 terms are used interchangeably in casual conversation. But in epidemiology, they have very precise, very specific meanings, and the examiners know that and they will test it. Disease control means the reduction of disease incidence, prevalence, morbidity, or mortality to an acceptable level. Notice what that definition does not say. It doesn't say 0. It says acceptable. This is ongoing work. You stop the program and the disease comes back. Think about mastitis control on a dairy farm. You're managing it constantly, it never goes away, and that's fine. Elimination takes it further. Elimination means the reduction of disease incidence to 0 in a defined geographic area, a country, a region. 0 cases, but the pathogen still exists somewhere in the world and it can re-enter. You still need surveillance, you still need border controls. A great example, rabies elimination from the United Kingdom. No cases in domestic animals, but they still test and monitor because the virus exists elsewhere. Eradication is the gold standard, the permanent reduction of worldwide incidence to 0. The pathogen no longer exists anywhere in nature. Once you achieve it, you don't need surveillance anymore. You don't need vaccination anymore. It's done. Only one animal disease in history has achieved this. Rinderpest, declared eradicated in 2011. In human medicine, smallpox in 1980. There's one more term worth knowing, extermination, which applies to eliminating a species, not a disease. And that's a whole different ethical and ecological conversation. The key distinction for your exam. Elimination is regional. The risk of reintroduction remains. Eradication is global and permanent. Disease can be eradicated, and that's not a defeatist statement. It's an epidemiological reality. Dowdle and others have given us a framework for thinking about eradication feasibility, and there are 6 criteria you need to know. Number 1, epidemiological vulnerability. Does the pathogen have a biological feature that makes it susceptible to elimination? Does it only infect one host species? Does it not survive long in the environment? Are there clear seasonal windows of transmission? These vulnerabilities are what we exploit. Number 2, an effective intervention exists. We need a vaccine or a test and remove strategy that can actually interrupt transmission, not just reduce it, but break the chain of infection entirely. Number three, practical deployable tools. The diagnostic tests need to be available, affordable, and usable in field conditions, not just in a reference laboratory in one country. Number four, demonstrated feasibility. Has regional elimination been achieved anywhere? If we can do it in one country, it's proof of concept that we can eventually do it everywhere. Number five, absence of a wildlife reservoir or a manageable one. This is the biggest one in practice. Wildlife reservoirs continuously reseed domestic animal populations. If you can't address the wildlife, you can't finish the job. We'll see this play out dramatically with brucellosis in Yellowstone. Number six, political and financial commitment. Eradication takes decades and requires sustained international cooperation across administrations, across budgets, across political cycles. This is harder than it sounds. Now let's apply these six criteria as a lens to Rinderpest. Single morbillivirus, effective live attenuated vaccine, excellent diagnostics, regional elimination achieved on multiple continents, no sustainable wildlife reservoir, and strong FAO-led political will. All six boxes? Checked. That's why it worked. With that framework in place, let's meet our first case study, and it's a story that starts with one of the most devastating animal diseases in history and ends with one of the greatest triumphs in veterinary public health. The name means cattle plague in German, and the name does not do justice to how catastrophic this disease was. We are talking about a morbillivirus, same family as measles and canine distemper, that caused morbidity and mortality exceeding 90% in naive cattle and buffalo populations. 90%. Let that sink in. In the 1890s, Rinderpest swept through sub-Saharan Africa in what historians now call the Great African Cattle Plague. It wiped out an estimated 90% of cattle on the continent. The knock-on effects on human food security were catastrophic. Famines followed and millions of people died. This was not just a veterinary problem. This was a humanitarian catastrophe driven by a virus in cattle. So when the Global Rinderpest Eradication Program, GREP, was launched by FAO in 1994, the stakes were enormous. GREP built on earlier regional work, the Pan-African Rinderpest Campaign, PARC, in Africa, and IMPRESS globally. The tool that made it possible was the Plowright tissue culture live attenuated vaccine. Safe, effective, a single dose confers lifelong immunity. Walter Plowright won the World Food Prize for developing it. GREP used a five-stage progressive framework. Stage 1 is preparedness. Stage 2 is active disease control, mass vaccination. Stage 3 is active surveillance with 0 clinical cases. Stage 4 is provisional freedom from disease. Stage 5 is full freedom from disease and virus. Countries had to demonstrate passage through each stage before progressing to the next. On May 25, 2011, the FAO and OIE made history. Rinderpest was officially declared globally eradicated, the second disease after smallpox ever eliminated from the face of the earth. All remaining laboratory stocks are now held under strict biosafety controls at only 2 authorized repositories, one in Russia, one in the UK. Here's an ACVPM exam tip. Rinderpest declared globally eradicated in 2011 by FAO and OIE. The causative agent is a morbillivirus of the Paramyxoviridae family. The key tool was the Plowright tissue culture live attenuated vaccine, single dose, lifelong immunity. GREP used a 5-stage progressive framework for country-level certification. Rinderpest is the only animal disease ever globally eradicated. 2 authorized laboratory repositories remain. Araya in Russia, and APHA Pirbright in the UK. So that's our global success story. Now let's come closer to home to a U.S. program that has been running since the 1930s, that got tantalizingly close to the finish line and then ran into a wall in the form of one of America's most iconic ecosystems. Talk about brucellosis, Brucella abortus in cattle, B. melitensis in goats and sheep. This is a zoonotic disease. It crosses from animals to people, causing undulant fever in humans, a miserable febrile illness that can become chronic. In cattle, it's reproductive devastation. Abortion storms, retained placentas, reduced fertility, the works. And because it's zoonotic, there's always a public health dimension layered on top of the animal health problem. The U.S. National Eradication Program started in the 1930s under USDA APHIS. The core strategy has always been test and remove combined with calfhood vaccination. States were classified in stages, stage 1 through stage 5, based on herd prevalence, and states with worse disease faced interstate movement restrictions on their cattle. That economic lever was powerful. Nation evolved over the program's history. Strain 19, S19, was the original live attenuated vaccine. Effective, but it has a critical flaw for an eradication program. It produces antibodies detectable by standard brucellosis serology. You can't tell a vaccinated animal from an infected one on a blood test. That's a surveillance nightmare. Inner strain RB51. This is a live attenuated rough LPS mutant. It's missing the smooth lipopolysaccharide that standard serology tests target. Vaccinate with RB51 and the animal builds immunity, but it doesn't produce the antibodies that the standard tests detect. That's DIVA, differentiation of infected from vaccinated animals. And we'll talk more about this concept later. By 2000, the continental United States was essentially free of brucellosis in cattle after nearly 70 years of sustained work. A remarkable achievement. And then Yellowstone. The Yellowstone problem is the textbook case study for why wildlife reservoirs are the single biggest obstacle to eradication, and it's absolutely fair game for your board's exam. The Greater Yellowstone ecosystem is one of the most ecologically intact temperate ecosystems in the world. It's home to about 5,000 free-ranging American bison and hundreds of thousands of elk. It is also, for our purposes, a massive uncontrolled reservoir of Brucella abortus, and it is the reason the U.S. cannot complete its brucellosis eradication program. Seroprevalence in Yellowstone bison can reach 40 to 60% in some herds. That's not a small problem you can manage around the edges. That's a deeply entrenched infection circulating in a population with no practical way to conduct the test and remove program you'd run in cattle. Every winter and spring, bison and elk migrate out of the park boundaries onto private and public lands that are also grazed by cattle. Every time that happens, there's a risk of wildlife to cattle spillover, and that risk, that theoretical possibility, is enough to prevent Montana, Wyoming, and Idaho from achieving federally recognized brucellosis-free status. The responses tried have included hunting and culling of bison at park boundaries, deeply controversial from both a cultural and conservation standpoint, remote vaccination of bison and elk using oral bait, and DART delivery of RB51, vaccination of cattle on affected grazing allotments, and livestock management changes to reduce the overlap between wildlife and cattle in time and space. None of these have solved the problem. This is the quote last mile problem in its most frustrating form. when the livestock half of the equation is solved, but an uncontrolled wildlife reservoir prevents the final elimination. Brucellosis in the greater Yellowstone area remains one of the most intractable challenges in U.S. veterinary public health today. Rabies virus, PRV, also called Aujeszky's disease virus or Suid herpes virus 1, is one of those pathogens where the clinical picture varies dramatically depending on who's infected. In pigs, which are the natural reservoir host, the signs are age dependent. Neonatal pigs suffer very high mortality. Growing pigs get respiratory disease. Adult breeding sows experience reproductive failure, late-term abortions, stillbirths, mummified fetuses. Before eradication, this was a significant cause of production losses across the U.S. swine industry. And then there are the non-pig species: cattle, sheep, dogs, cats, wild carnivores. They are all dead-end hosts. If a cow or a dog gets PRV, there is no recovery. They develop, quote, mad itch, an intensely pruritic, fatal neurological syndrome. It earned the name the mad itch disease for good reason. The U.S. eradication program launched in 1989 with a 15-year target timeline. And the key innovation that made it work was the GE-deleted DIVA vaccine. Here's the elegant logic. Wild-type PRV produces antibodies to glycoprotein E, GE. If you delete the GE gene from the vaccine strain, vaccinated animals develop solid immunity, but they never produce anti-GE antibody. Now you have a companion diagnostic, a GE-specific ELISA. If an animal is GE negative, it's been vaccinated but not naturally infected. If it's GE positive, it has seen wild-type virus and is infected or exposed. The test distinguishes them perfectly. The program used market chain testing at slaughter, to detect GE positive animals in commercial swine, then tracing movement records backward to identify the infected herd of origin. It was a brilliantly designed surveillance system that worked at scale across the entire commercial swine industry. In 2004, the United States declared itself free of pseudorabies in commercial swine, a complete eradication from domestic pigs in 15 years. On schedule, a model program. The shared factors that appear in every program that succeeds. There's a pattern here worth memorizing. What did Rinderpest and Pseudorabies have in common, and what can we take forward to design future eradication programs? Let's lay out the success factors because these are worth committing to memory. They're the blueprint for any eradication effort. Clear, measurable, time-bound goals with stage-based milestones. Both GREP and the PRV program used stage-based frameworks. You knew exactly what you had to demonstrate to move to the next stage. No ambiguity, no moving goalposts. A single effective field deployable diagnostic test for Rinderpest, ELISA, and competitive ELISA. For PRV, GE, ELISA. Farmers and field vets could use these. They didn't require specialized equipment in distant reference labs. A DIVA vaccine enabling simultaneous vaccination and surveillance. This is non-negotiable for any modern eradication program. Without it, you're flying blind during the vaccination phase. Market chain testing. Using the commercial slaughter pipeline as a passive surveillance system is elegant and economically efficient. You're testing animals that were going to be processed anyway. For PRV, this identified infected premises through movement traceback. Movement controls and traceability. You can't do traceback if you don't know where the animal came from. Robust animal identification and movement recording systems are infrastructure that pays dividends across multiple programs. Sustained funding. Eradication programs are not cheap, but they are almost always cheaper than indefinite control. The Rinderpest eradication is estimated to save billions of dollars annually in control costs that are now no longer necessary. International cooperation and shared surveillance. Disease does not respect political borders. Information does, unless we build systems that share it. Strong stakeholder engagement. Producer buy-in is not optional. Compliance drives the program. Enforcement alone never wins. Spent a lot of time now on successes and near successes, but we learn just as much, perhaps more, from understanding why programs fail. Let's talk about the pitfalls. If eradication were easy, every country would have done it for every disease by now. It's not easy, and programs fail, sometimes spectacularly. Understanding why is just as important as understanding why they succeed, and the boards will ask you about this. So let's go through the major failure modes. Wildlife reservoirs. You already know this one. It's the most common cause of failure in modern programs. We've seen it with brucellosis in Yellowstone. We see it with bovine tuberculosis in the UK, where badgers maintain M. bovis independent of the cattle population. We see it with FMD in sub-Saharan Africa, where African buffalo are a major reservoir. If you cannot address the wildlife side, you cannot finish the job. Funding discontinuity. Eradication programs take decades. That means they outlast multiple government administrations, multiple budget cycles, multiple political priorities. When funding gets cut before the program reaches the final stage, disease rebounds, and you've wasted all the prior investment. The last mile problem. The final few percent of infected farms or animals are disproportionately difficult to find. The surveillance tools that worked efficiently at high prevalence often miss cases at very low prevalence because the signal to noise ratio collapses. Cross-border reintroduction. Even a successful national elimination program can be undone overnight by reintroduction from a neighboring country that has not eradicated. This is why regional and global cooperation matters so much. Low compliance. Producers who don't report disease, who avoid testing, who violate movement controls, who resist depopulation. These behaviors break the chain of surveillance and control that the program depends on. Biological constraints. Some diseases are just harder by their nature. Multiple host species, long environmental survival, very short detectable windows before slaughter. You can't overcome biology with policy alone. Do a rapid feasibility analysis on 3 diseases using our 6 criteria as the lens. This is exactly the kind of applied thinking the ACVPM exam rewards. Foot and mouth disease, FMD. There's actually a strong biological case for eradication. The pathogen only causes sustained transmission in livestock and certain wildlife. Effective vaccines exist, and DIVA capability is achievable with some vaccine platforms. But eradication is blocked by multiple factors. Wildlife reservoirs. African buffalo are a major FMD reservoir in sub-Saharan Africa. Extraordinarily high transmissibility, the basic reproduction number R naught can exceed 10 in naive populations, meaning you need incredibly high vaccination coverage to interrupt transmission. And the political challenge of getting global agreement and sustained funding across 193 countries is enormous. The OIE maintains an FMD roadmap with progressive control stages toward regional elimination. That's realistic. Global eradication is a very long way off. Bovine viral diarrhea virus, BVDV. This one is genuinely exciting. Several northern European countries, Norway, Sweden, Finland, Denmark, Scotland, have achieved or are approaching national elimination of BVDV without vaccination. The strategy is conceptually simple. Identify and remove all persistently infected, PI animals. PI cattle, born to acutely infected dams during early gestation, are immunotolerant to BVDV and shed virus continuously for life. Ear notch ELISA at birth identifies PIs. Remove all PIs and you remove the primary reservoir. The U.S. Voluntary program, incomplete participation, no national coordination, no eradication pathway currently exists. Johne's disease, paratuberculosis. This is the hard one. Mycobacterium avium subspecies paratuberculosis has an extremely long incubation period, 2 to 10 years, meaning animals can be infected and shedding for years before they show clinical signs. Test sensitivity in early stage infection is poor. There is no effective sterilizing vaccine, and MAP can persist in the environment for years. For Johne's, the realistic goal is control, not eradication, and even good control requires enormous sustained effort. A lot of ground. Let's bring it all together with a summary of the key takeaways and an exam strategy to make sure you walk into that board exam ready. Terminology. Control reduces burden. Ongoing effort required. Elimination zeros out cases in a region. Reintroduction risk remains. Eradication is permanent global elimination. No pathogen, no program needed. Know which is which. The boards will absolutely test this. The 6 feasibility criteria: epidemiological vulnerability, effective intervention, practical tools, demonstrated regional elimination, no unmanageable wildlife reservoir, and sustained political financial commitment. Apply these to any disease the exam puts in front of you, and you have a framework for any question they can throw at you. Rinderpest, morbillivirus, declared eradicated in 2011 by FAO and OIE. Plowright tissue culture vaccine, 5-stage GREP framework, FAO-led global coordination. The only animal disease ever globally eradicated. Know it cold. Brucellosis, nearly eradicated from U.S. livestock, stalled by the Yellowstone Wildlife Reservoir. Bison and elk seroprevalence 40 to 60%. This is your classic wildlife reservoir case. RB51 is the DIVA vaccine. Rough LPS mutant, no smooth LPS antibodies. Surveillance can continue in vaccinated herds. Pseudorabies, eradicated from U.S. commercial swine in 2004. GE deleted DIVA vaccine plus market chain testing at slaughter plus movement traceback, a model for what a well-designed eradication program looks like. The DIVA concept, negative marker approach, delete an antigen from the vaccine, run a companion diagnostic for antibody to that antigen. Vaccinated are negative, infected are positive, allows simultaneous vaccination and surveillance. This is a concept that appears across multiple diseases and across multiple exam questions. If you found this video helpful, please like and subscribe, and I'll see you for the next module, where we're going to step outside the barn and look at the landscape, environmental epidemiology, and agroecosystems. Thanks for joining, and I'll see you there.